Hello, my dear students. Today we are going to see Science Part 1, Lesson number 10, that is Space Mission. Before starting this lesson, four questions they have given in Can You Recall? The first question is that what is the difference between space and sky? तो स्पेस और स्काई में क्या डिफरेंस है वो हमें यहाँ पे बताना है. विजिबल पोर्शन सीन बाय आईज इज स्काई. स्काई क्या होता है? स्काई ये एक विजिबल पोर्शन होता है जो हमारे आँखों से हमें दिखता है. सिमिलर वे इफ यू सी हियर अबाउट स्पेस, space is infinite distance object in that solar system is coming, after that stars, galaxy, and this is called as space. Second question, what are different objects in the solar system? सोलर सिस्टम में देखा जाए तो कि कौन कौन से ऑब्जेक्ट्स है, डिफरेंट ऑब्जेक्ट्स, वो हमें यहाँ पे मेंशन करने हैं. तो पहला वाला देखा जाए तो मर्क्यूरी होती है, वेनस, आफ्टर दैट अर्थ इज़ देयर, मार्स, जुपिटर, सैटर्न, यूरेनस, नेपच्यून एंड सन. ये जो सन होता है, सन इज़ द सेंटर ऑफ ऑल दिस सोलर सिस्टम. तो सन जो होता है वो सन क्या होता है? सभी सोलर सिस्टम का ये एक सेंटर होता है और उसके अराउंड सभी प्लैनेट्स क्या होते हैं? ऑर्बिटली घूमते हैं. थर्ड क्वेश्चन, व्हाट इज़ मीन बाय सैटेलाइट? अभी सैटेलाइट क्या होता है? सैटेलाइट ये क्या है? इट इज़ एन एस्ट्रोनॉमिकल ऑब्जेक्ट ऑर्बिटिंग एंड प्लैनेट ऑफ आवर सोलर सिस्टम इज़ कॉल्ड सैटेलाइट. तो ये क्या होता है? सैटेलाइट एक एस्ट्रोनॉमिकल ऑब्जेक्ट होता है कि वो ऑर्बिट करता है प्लैनेट के अराउंड और उसी सोलर सिस्टम के अराउंड वो क्या होता है? घूमता रहता है. तो उसको कहते हैं सैटेलाइट. नाउ फोर्थ क्वेश्चन इन दैट सी, हाउ मेनी नेचुरल सैटेलाइट डज द अर्थ हैव? जो अर्थ होता है उसको नेचुरल सैटेलाइट्स कौन कौन से होते हैं वो हमें यहाँ पे मेंशन करने हैं. तो देखा जाए तो अर्थ जो है, अर्थ के अराउंड ओनली एक ही प्लैनेट है कि वो क्या करता है? रिवॉल्व करता है. नेचुरल सैटेलाइट देखा जाए तो नेचुरल सैटेलाइट एक ही है और वो कौन सा है? मून. द अर्थ हैज़ ओनली नेचुरल सैटेलाइट दैट इज़ कॉल्ड एज मून. तो मून ये जो होता है, मून यही एक नेचुरल सैटेलाइट है कि जो अर्थ के अराउंड रिवॉल्व होता है. नाउ वी विल कम टू आवर मेन पॉइंट ऑफ दिस चैप्टर ऑफ स्पेस मिशन. इन दैट सी इंट्रोडक्शन, man has always been curious about unknown places and he has always been eager to expand the horizon of his knowledge by exploring the unknown world. He must have had deep curiosity about the space and the many things such as twinkling of stars in the dark sky. He must have dreamed to fly to the space and must have been working for that. Man has stepped up onto the moon. Also, he had sent some spacecraft for collecting information about the unknown facts in the universe. Let us study how it has become possible. Substantial development in the technologies, especially space technology, in the latter half of 20th century resulted in the development of spacecraft, making space voyages possible. Since then, more than 1,000 artificial satellites have been placed into the orbit around the Earth. Additionally, space missions have been undertaken for close observations of various objects in the solar system. We will learn about these in this chapter. Mission, we can clarify the space mission into two categories. In one type of mission, the objective is put artificial satellite in orbit around the Earth for research and various other useful applications. In objective of the second type of mission is to send the spacecraft to the outer space for close observation and understanding the objects in the solar system or even outside the solar system. Need and importance of space mission. The world has become a global village due to the space mission. Today, we can contact a person in any part of the world within a second. We can gather information about worldwide events sitting at home. You all know the importance of internet. Due to internet, every information is available at your fingertip. It has become possible to get advance alert about natural calamities and take proper precautions. During war, it is possible to get information about the action of enemy through artificial satellite surveillance using satellite. It is also possible to explore the fossil reservoirs and minerals in the earth. Thus, there are ultimate applications of space mission. Today, space technology is an inevitable part of development of a nation. Now, let us know about the artificial satellite. A natural satellite is an astronomical object orbiting the Earth or any other planet. The Moon is the only natural satellite of the Earth. Some other planets in the solar system have than one natural satellite. Similarly, if a man-made object revolves around the Earth or any other planet in a fixed orbit, it is called the artificial satellite. The first artificial satellite, that was the Sputnik, was sent to the space by Soviet Union in 1957. Today, more than 1000 satellites are orbiting the Earth. The satellite works on solar energy. So, solar photovoltaic panels are attached on both the sides of this satellite like wings. Instruments are installed in the satellite to receive and transmit signals from and to the earth. The satellite have various other types of instruments depending on their functions. One such satellite is shown in figure 10.1. Signal transmitted from the earth to the satellite and from the satellite to a mobile tower and mobile phone are also shown. These satellites are sent into the space to perform various functions. Depending on their function, satellites are classified into following categories. In that, if we see first, that is INSAT, that is Indian National Satellite. Second, GSAT, Geosynchronous Satellite. Third one, IRNSS, that is Indian Regional Navigation Satellite System. Next one, IRS, that is Indian Remote Sensing Satellite. And next one, that is GSLV, Geosynchronous Satellite Launch Vehicle. And last one, that is PSLV, that is Polar Satellite Launch Vehicle. Here, more information about these Indian satellites we will see next. The weather satellite studies are given here. Weather satellite in that INSAT and GSAT are used. Second type of satellite, that is communication satellite, establish communication between the different locations in the world through use of specific waves. In that, the name if we see, that is INSAT and GSAT. This type of launch vehicles are used in it. Next type of a satellite, that is broadcast satellite. In that, the name of the satellite is INSAT and GSAT. Next one, type of satellite, the function of navigation satellite, to fix the location of any place on the surface of the earth in terms of its various precise longitudes, latitudes and altitudes. Now next one, the satellite, if we see, that is the military satellite, it is used to collect the information for security purpose. In that, whatever the satellite series is used, that is many different types of series are used. In that, the purpose, if we see, these are the purpose for what we are using it. The earth observation satellite is also used for observations and guidance. In that IRS, this type of satellite we are using this series. Second one, that is INSAT, GSAT and IRNS. This type of launch vehicles we are using. Now next one, we will see the orbits of artificial satellite. All artificial satellites do not revolve in similar orbit around the earth. The functions of the satellite decides the height of the satellite, orbits from the earth's surface, the nature of the object and orbit, it is maybe circular or elliptical, and whether the orbit shall be perpendicular to the equatorial plane or making some angle with it. To put the satellite in its proper orbit at a specific height above the earth's surface, the satellite is taken to the height using a satellite launch vehicle. In this, see here, whatever the specific velocity, that is the critical velocity, and it is denoted by VC. The satellite then starts revolving. Now next one, we will see how to determine the critical velocity. If a satellite of mass m is revolving around the earth in an orbit of height h with speed vc, then as seen in the chapter of gravitation, the centripetal force, that is equal to mvc square upon r, will act on it. Here r is the orbital radius of a satellite from the center of the earth. This centripetal force is provided by the gravity of the earth. Therefore, the centripetal force, that will be equal to the gravitational force between the earth and the satellite. Here mvc square upon r plus h will be equal to gmm upon r plus h square. Here vc square will be equal to gm upon r plus h. So vc, that is critical velocity, will be equal to under root gm upon r plus h. This will be the final equation for critical velocity. Now in this, g, that is the capital G, is gravitational constant and its value is 6.67 into 10 raised to 11 Newton meter square per kilogram square. Here capital M is the mass of the earth and its value is 6 into 10 raised to 24 kg. Here capital R, that is the radius of the earth and its value is 6.4 into 10 raised to 6 meter, that is equal to 6,400 kilometer. Here small h is the height of satellite above the surface of the earth. So r plus h is the radius of the orbit of the satellite. It can be seen that the critical velocity does not depend upon the mass of the satellite. As the height of a satellite orbits from the earth's surface increases, the critical velocity decreases. Depending on the height of a satellite orbit about the earth's surface, the satellite orbits are classified as below. High earth orbit, that is height from the earth's surface greater than 35,780 kilometers. If the height of a satellite orbit above the earth's surface is greater than or equal to 35,700 kilometers, The orbit is called high Earth orbit. As we will see in the next example, a satellite revolving in an orbit 35,780 km above the Earth's surface will take around 24 hours to complete one revolution. We know that Earth also takes almost 24 hours for one revolution. If the satellite is revolving in an orbit parallel to the equatorial plane, the time of revolution for the Earth around itself and that for the satellite to revolve around the Earth being the same. The satellite will appear to be stationary with respect to the Earth. For a passenger in a vehicle, another vehicle moving parallel to him with equatorial velocity and equal velocity appears to be stationary. This is what happens here also. These satellites are therefore called as geosynchronous satellites. Since these satellites are stationary with reference to the Earth, they can observe a space portion of the Earth continuously. Therefore, they are used in applications like telephone, television, radio, etc. Now next one, that is medium Earth orbit. Height above the Earth's surface, that is 2000 km to 35,780 km. If the height of the satellite orbit above the Earth's surface in between 2000 km and 35,700 km, the orbits are called as medium Earth orbit. The geostationary satellite orbit above the equator. These are therefore not useful to study the polar regions. For this purpose, elliptical mediums Earth orbit passing over the polar regions are used. These orbits are called polar orbits. In this orbit, the satellite complete one revolution in 2 to 24 hours. Now next one, that is some of these satellites revolve in a circular orbit at a height around 20,200 kilometers above the Earth's surface. Global positioning satellite revolves in such orbit. Next one, low Earth orbit. Height above the Earth's surface, that is 180 km to 2000 km. If the height of a satellite above the Earth's surface is between 180 km and 2000 km to the orbit are called as low Earth orbit. The satellite used for scientific experiments and atmospheric studies revolved in low Earth orbit depending on the height of the object. They complete one revolution in 90 minutes. Internal space stations and Hubble telescope also revolves in low Earth orbit.